Hello, welcome back to Learn Physics. In today's topic, we are starting a new chapter, that is thermal properties of matter. Okay, in this first term we are going to study as heat. What is meant by heat? Heat is a form of energy which gives warmth. Okay, that means hotness or coldness. Form of energy which gives warmth, hotness or coldness. That is called a heat. Unit of heat energy is joule. Representation as J. Another unit is calorie. Calorie is CAL. Like that we will represent. 1 calorie equals 4.2 joule. So how we can define the unit of heat energy? Unit of heat energy is joule. So how we will be defining joule? Here it is, if I am considering 1 kilogram of mass, and in that mass if I am raising the temperature by 1 degree Celsius, usually that is 14.5 degrees Celsius to 15.5 degrees Celsius of water. That is the standard thing which we are considering, but you can say it is 1 kilogram of substance. For a 1 degree rise of temperature, the amount of heat energy required is called as 1 joule. Okay, so 1 joule is the amount of heat energy required to raise the temperature by 1 degree Celsius in 1 kilogram mass. That is heat. Okay, so next is temperature. So how we will define temperature? Temperature is the measure of, hotness or coldness. That is the measure of hotness or coldness of an object of a body is called as temperature. It is the measure of hotness or coldness of a body. Now, what will be the unit of temperature? The temperature has different unit, that is degree Celsius. We have temperature has an unit of degrees Celsius, and another unit is Fahrenheit. Fahrenheit we have, and Kelvin scale we have. First we are going to consider about the degree Celsius and this Fahrenheit. So degree Celsius is its ice point, and I told you it is about the measure of hotness or coldness. Hotness maximum value is 100 degrees Celsius, isn't it? And coldness ice point and that is freezing point and boiling point we will be considering. So here it is 0 degrees Celsius. But in the case of Fahrenheit scale, it is 32 degree Fahrenheit for the 0 degrees Celsius and 212 degree Fahrenheit for the hotness, that is boiling point. Okay, 212 degree Fahrenheit. So in the case of degree Celsius, the scale, that is degree Celsius, while we are taking Celsius scale thermometers, if we are using, the temperature is measured using the instrument called a thermometer. So in the case of thermometer, if I am using a thermometer, it will be measuring from 0 degrees Celsius to 100 degrees Celsius. But it is having a value, 100 divisions will be there in the case of Celsius scale. 100 division, each division will be 1 degree Celsius. Okay, but in the case of Fahrenheit scale, it will be 180 divisions. 180 divisions will be there, each will be equally divided. Okay, so 180 divisions will be there, each will be equally divided in the case of Fahrenheit scale. So 32 degree Fahrenheit to 212 degree Fahrenheit. So what is the relation connecting this Celsius scale and Fahrenheit scale? Celsius scale's temperature is Tc minus 0 divided by 100 equals Tf minus 32 divided by 180. This is the relation connecting Celsius scale and Fahrenheit scale. Okay, Tc minus 0 divided by 100 equals Tf minus 32 by 180. So if we are cancelling all these things and making it into simple form, we will get it as Tc by 5 equals Tf minus 32 divided by 9. This is the relation which we are getting it in the case of connection between Celsius scale and Fahrenheit. Okay, Tc by 5 equals Tf minus 32 divided by 9. Okay, clear? So next we are going to study about the absolute zero scale or Kelvin scale. Okay, so next we are going to study about the ideal gas equation. Ideal gas equation. What is this ideal gas equation? In thermodynamics, it is Boyle's law, Charles' law. These two laws we should know for finding out this ideal gas equation. And according to Boyle's law, pressure acting on a substance will be directly proportional to 1 by V. That is, pressure acting on a system is inversely proportional to volume. Okay, or we can say it is PV will be equal to constant. Okay, this will happen only at if temperature is constant. We are keeping temperature as constant, and then pressure volume variation while we are considering, we can understand that P is inversely proportional to volume. Okay, and Charles' law states that V is directly proportional to T. Okay, PV is PV is a constant. Here it is V by T is a constant. Okay, this will be at constant pressure. Pressure we are keeping it constant, then V is proportional to T, and that is Charles' law. If Boyle's law states that P is inversely proportional to V when T is kept a constant. Okay, so P is proportional to. So while we are combining these two, we will get it as PV by T is a constant. Okay, we will get it as PV by T is a constant, or we can say PV equals R into T. R is called the universal gas constant, and then if n number of moles are there, then we can say PV equals nRT. N is the number of moles. And R is the universal gas constant, and its value is 8.3 joule per mole per Kelvin. Okay, so this is universal gas constant is represented by the symbol using Kelvin scale, joule per mole per Kelvin. So understood. So this is your ideal gas equation. PV equals nRT. So PV is equal to P is the pressure, V volume, T temperature. Okay. So here if we are considering the pressure and temperature, okay, keeping the volume constant, how it will be varying? If volume is constant, we can write it as P is proportional to T. Isn't it? So we are going to draw a diagram connecting pressure and temperature. Okay, if I am drawing a graph like this, temperature, and here it is pressure. Okay, and I am taking this as 0 degrees Celsius at constant volume, volume keeping constant. Okay, so we will get a graph like this. So if we are extending this graph, we can see that it will be coming to this point, that is minus 273.15 degrees Celsius. Okay, at this temperature, pressure will remain 0 and volume is a constant, isn't it? So this temperature is called as absolute zero. And Kelvin stated that this as the Kelvin scale, that is 0 Kelvin, that is starting from minus 273 degrees Celsius. Okay, so this is the absolute zero scale. So that scale is known as absolute zero scale or Kelvin scale. Okay, clear how we are finding out the values here. So ideal gas equation using Boyle's law and Charles' law, we wrote it as P is inversely proportional to V and V is directly proportional to T at constant pressure, that is Charles' law. So combining these two, we get it as PV by T is a constant, PV equals nRT, that is ideal gas equation. But in that we can consider if volume is constant, P is proportional to T, isn't it? So while we are drawing the graph, that will be a straight line graph, and while we are extrapolating that to the left side, we will get it as at a constant, when pressure is equal to 0, temperature will be minus 273.15 degrees Celsius. So that is 0 degrees Celsius, that is called as Kelvin scale. So to come to 0 degree, that is 0, what we should do to the degree Celsius scale, we should add 273 to reach to the Kelvin scale. Okay, temperature at Kelvin scale, we should add 273 because minus 273 degree 0.15 degrees Celsius is considered as the starting, that is absolute ice point. Ice point in Kelvin scale is minus 273.15 degrees Celsius. That is ice point in Kelvin scale. Okay, so understood. So we are this is absolute zero. Absolute zero value is minus 273.15 degrees Celsius. In Kelvin scale, ice point is 273. 273 Kelvin will be the ice point of, and 373 will be the boiling point of in Kelvin scale. Okay, so minus 273.15 degrees Celsius is called as absolute zero. Why? Because it is the pressure is equal to 0 when volume is constant. In that, temperature pressure will be equal to 0. Okay, clear? So this Kelvin scale, Fahrenheit and degrees Celsius scale, you understood? Next is thermal expansion. What is meant by thermal expansion? See, in that word itself it is there, thermal expansion. As temperature gives to the system, all the solids will be expanding. Okay, when temperature gives to a solid, it will expand. That is called as thermal expansion. This thermal expansion can happen in three ways. That is, its lengthwise its increase, and area wise its increase, and volume wise it will increase. Okay, so here if lengthwise if it is increasing, that is called as linear expansion. Okay, and areal wise if it is increasing, or it is called areal expansion. Areal expansion. And if volume wise if it is increasing, it is called as volume expansion. Okay, so area is increasing, that is areal expansion, volume increasing, volume expansion, linear lengthwise if it is increasing, it is called as linear expansion. So how we can find out this areal expansion? The increase in length delta L is directly proportional to the total length of the material, and delta L is directly proportional to the change in temperature. Okay, so we can write it as delta L is proportional to L delta T, or we can write it as delta L equals alpha L into L delta T, or this alpha L is called as coefficient of linear expansion. Okay, this is called as coefficient of linear expansion, alpha L. Okay, so understood, delta L equals alpha L into delta L. So increase in length is directly proportional to length and is directly proportional to change in temperature. So it is delta L is equal to alpha L into L delta T. Okay, in the same way we can write it for areal expansion also. Delta A is proportional to A, delta A is proportional to delta T, or we can write it as delta A is proportional to A delta T, or we can write it as delta A equals alpha A into A delta T. This is called as coefficient of areal expansion. coefficient of areal expansion. In the same way, if volume, if it is increasing, we can write it as, you tell me how it will be, delta V is proportional to V delta T, or we can write it as delta V equals alpha V into V delta T. Okay, alpha V is called a coefficient of volume expansion. Okay, so this is, so there will be a relation connecting this alpha L, alpha A and alpha V. So understood, it is all increments will be directly proportional to its respective dimensions, and will be the increase in area or increase in length or increase in volume or and temperature also. What is the change in temperature? It depends on that also. Okay, so understood thermal expansion. So in the case of, so this is about the solids we told, but in the case of fluids also we can say this anomalous expansion of water. Expansion of water is very important. That is change which is happening in the case of water. Okay, so it is a volume expansion while we are considering. See, one full bottle of water we are taking and closing it tightly, or if it is if it is a glass bottle and I am taking full water and keeping it inside the fridge. Okay, then when it gets freeze, I can see that it will break. Thus that glass bottle will break. The reason is water, usually if we are temperature is decreasing, what will happen? The volume also will decrease. As temperature, volume will be decreasing as temperature decreases. Okay, as temperature decreases, volume also will be decreasing. Okay, so but in the case of water, this decrease will happen only till 4 degrees Celsius. Okay, volume will be decreasing till 4 degrees Celsius. After that 4 degrees Celsius, if temperature decreases, volume will be expanding. Okay, volume will be, it will be expansion, will not compression, expansion will be happening. So this behavior of water is called as anomalous expansion. That is the reason it is glass bottle is breaking. Okay, glass bottle will break because of the anomalous expansion of water. The reason is, see, this one will be very useful in nature. The reason is, see, we know in cold regions and all, in cold regions what will, but how the sea animals will be existing there, or water animals will be existing in cold regions, because if when it become very hot, it will become ice, right? So then how it can exist in ice instead of water? Okay, so there what is happening is, when till 4 degrees Celsius volume will decrease. As volume decreasing, what will happen? See, density equals mass by volume. Okay, as volume decreases, what will happen? Density will increase. If density increasing, what will happen? It will be flowing up, isn't it? So it will be flowing up and the rest will be coming down. We know that density equals mass by volume. As volume decreases, what will happen? Density will increase. If density increasing, this will comes down, but now also it is not coming to the ice point, isn't it? 0 degrees Celsius is the ice point. So 4 degrees Celsius itself, density will be increasing and it will come down. Okay, so water will be coming in the lower layer and the rest of the things will be going up. There again 4 degrees Celsius, when it comes to 4 degrees Celsius, density will be increasing and it will come down. Okay, as density increases, it will sink, isn't it? So the top layer, when it is in freeze, ice become, it is volume is more. Volume is more means density will be less. So in only at the top surface, ice will be there. But below that one, what will be only? It will be water itself. So water animals and won't be having an issue in winter season in cold region. Okay, in cold regions, what is, I will explain you once more. As temperature increases, usually as temperature increases, volume also will increase. But in the case of water, as temperature increases, so here is from 100 degrees Celsius, water temperature is decreasing. So according to that, volume also will decrease. As temperature increases, volume also will increase, isn't it? This is what happening. But only in the case of ice, this phenomena will happen only till 4 degrees Celsius. After 4 degrees Celsius, if we are decreasing the temperature, what will happen? Volume will increase. If volume increasing, density will decrease, because volume is coming in the denominator. So density, volume increases, density will be decreasing. If density decreases, what will happen? It will float. Okay, so the water which is having a temperature of 4 degrees Celsius will be in the lower layer, and the upper layer it will be freeze down. Okay, so which is becoming as ice, it will go into the upper layer, and in lower layers it will exist as water only. Okay, so understood, this is what happening in the case of this anomalous expansion. Okay, understood how this anomalous expansion of water is useful in our nature. So clear, this thermal expansion, aerial expansion, volume expansion and all. Now we need to find out the derivation or a relation connecting this linear expansion, aerial expansion and volume expansion. Okay, that one we will do it in the next class. Well, if you got this, okay, it's easy, I think. Okay, and so I'm winding up for today. If you like the channel, please don't forget to subscribe. Thank you for watching. Bye.